Hi, my name is Simon Yokishis, and in this tutorial we're gonna have a look at decorators in Python. Now, decorators provide a powerful way of enhancing a function with some more functionality by wrapping a function into another function without modifying the original function. Now, if this sounds weird to you, bear with me, we'll have a look at how this works using different examples. In general, decorators can help us to write shorter, cleaner, and more elegant code. Now, if you've never seen or worked with decorators, they might look a little bit strange, and it might also take a little bit of time to fully understand them, but knowing how to use them and when to use them will definitely enhance your programming. In this tutorial, we'll first have a general look at what decorators are and how they work. Afterwards, we see some general examples, and at the end of this tutorial, we'll have a look at a real-world example to see how we can use decorators inside Nuke to create more elegant and more maintainable code and reduce code duplication. So let's get started. Now, to understand how decorators work, we'll first need to have a look at some important concepts in Python. Now, in Python, everything is an object. Integers, strings, lists, dictionaries, class instances, they are all objects. But also functions are objects. They are often called first-class objects. Let's have a look at some examples here. So in here we have a function, hello, which prints hello to the console. And we can invoke it using hello with round brackets. But we can also print the function without invoking it, so without using round brackets in here. This will print the function object's memory address to the console. As this is an object like any other objects, we can store it in another variable. For instance, my function. If we print this variable and the original hello function object, they point to the same memory address. This also means that we can invoke the hello function using my function. So my function becomes a reference or an alias to our hello function. Now, as functions are objects, we can pass them to other functions as well. These functions are so-called higher order functions because they take another function as argument. And this becomes very powerful. In here we have another function, let's call it wrapper, that takes a function object as argument. So the wrapper function is our higher order function. In this function we print some value and the function object. To invoke our wrapper, let's write wrapper and pass in the hello function object as argument. Now pay attention to not use round brackets for our argument. We don't want to call our hello function here. We want to pass in its function object. So let's run this, and we get my argument is and the function object for hello. Perfect. Now we can also implement functions inside functions and invoke these. Let's have a look at the next example. In here we implement a function outer, in which we print outer to the console. And inside this function we implement another function called inner, which prints inner. And we call this function inside our outer function. So when we invoke outer, we get outer inner. Because again, we print outer and then we invoke the inner function right inside our outer function to print inner. So let's quickly recap what we've learned so far. Functions are first-class objects, and we can store their function objects inside other variables and pass them to other functions, which make these functions higher-order functions. And that we can define functions inside functions. We can now bring these concepts together. In here we have a function called printinfo, which takes a function object as argument. So this is a higher-order function. And in here we create a function called wrapper, in which we print before function to the console. Then we use our function object and invoke it using round brackets, and print after function to the console. So we basically wrap executing our function between print statements. This enables us to execute code before we execute our actual function and after we execute our actual function. And in the end we return the wrapped function, which does all of that as a function object. So again, we're not invoking anything here. We're simply returning function objects in here. In order to test this higher order function, we create another function called world, which prints world to the console. As we've previously learned, we can now do the following. We create a new variable called myfunc and assign printinfo with the argument of our function object world to it. If we print myfunc, we're basically using our wrapper function object. And if we invoke it, we get our result. Our print statement before the actual function execution then the function execution, and the print statement after the function execution. So this enables us now to execute code before and after a function execution without touching the code of our initial function. And this concept becomes very powerful due to several reasons. What if we want to execute some code before several functions or after several functions, or both? We basically need to implement our logic once and can invoke it for several function objects. Now, there's a shortcut to assigning our wrapper function to a variable that uses our function object and invoking this variable. Using the add operator, we can add the same behavior. This is called applying syntactic sugar. So this is simply a short form of that. It means before we actually invoke this, we pass it to that function, and inside that function we invoke it and do some other stuff. Perfect. Now, in case this is the first time you're seeing decorators, it might take a bit of time to fully understand what's going on here. But trust me, having understood this concept will definitely enhance your Python skills and will enable you to write more performant, more elegant, and shorter code. Let's have a look at how we can pass in additional arguments to our decorators. So in here we have another decorator called printInfo, which takes in a function object. Inside the wrapper we can use *args to pass in a variable length of arguments. And let's store the function that we are calling and all the arguments in a list. So we add the function object to a list and unpack all the entered arguments using a for loop, in which we add each passed-in argument to our list. We'll then print that list, execute our actual function and store its return value inside a variable, print to the console that we're finished executing the actual function, and print the information list one more time and return the actual calculated result of our function execution. Now we decorate our hello function, which simply prints hello to the console with our printInfo function. So if we execute the hello function, we get the print statement executing and then the function object. Now in this case our original hello function does not take any arguments, so that the information list only includes our function object. Then we execute our hello function and then we use another print statement. Perfect. Let's see how this looks like when we decorate a function that takes in arguments. In here we have a function called repeat that will repeat the given word x times, where x is the amount that we specify in the count argument. And we also decorate it using our printInfo function. If we import this function and execute it, this is what we get. Let's for example repeat hello 3 times. So repeat hello 3. And here we get the list containing our repeat function object and all passed in arguments, in this case hello and 3. Now as we're using a *args, we can simply unpack all the arguments using a for loop and don't need to hardcode any number of arguments in here, which is nice. Because as we've seen, this works with functions that have no arguments, and this works also with functions that have 2 arguments, and this will also work with functions that have 100 arguments. It doesn't really matter how many arguments we pass to our decorator. Okay, up to this point, these examples were all quite theoretically. Let's have a look at some real-world examples where using decorators might become useful. Let's say we have several functions in which we want to do various calculations. Now, for the sake of simplification, let's keep these functions very simple. So here are 2 examples for some calculations. The first function multiply will multiply its given value with itself and return the result. The second function will add 2 numbers and return the sum. Now, these functions are very simple, but let's keep them like so for now, so that we can easily see where decorators can be useful. So let's say that these functions require that we pass in integer values only. Now, when executing these functions, let's also say that the passed-in arguments might come from some untrusted sources. So for example, from reading a CSV file or from a database or simply from a user input. In this case, we cannot be sure that integer values were passed in. Now, we could create some type checks inside both functions, but this would create a lot of code duplication. Wouldn't it be better to do some type checks before executing the actual function? And you guessed correctly, this is where we can use decorators. Now, in here we define a decorator called ensure integer arguments. So we pass in our function object as argument. And in our wrapper function, we pass in all arguments from our function, as we have seen above. Now in here we iterate over all arguments and check if the current argument of our for loop is of integer type. If it's not, we raise a value error with a clear and easy to understand error message, where we print the name of the actual function to execute, and error invalid non-integer type 4, and then we use the index of the argument that we passed in using an enumerate. And to make the error very clear to the user, we print the actual argument that we passed in. So let's see that in action. So if we execute multiply using an integer, we get the correct result. So in this case we multiply 3 by 3, which is 9. But if we pass in a non-integer type, for instance a string like hello, we get a very clear error message. Multiply, which is the function that we executed, invalid non-integer value for first argument, hello. And we see that the actual multiply function did not get executed because we raised a value error before executing the function. Now, the nice thing about having this check as a decorator is that we can now simply add it to as many other functions as we like. So here we use the same decorator for our add function to ensure that only integer values are passed in. If we pass in add 4 and 2, we get the correct result of 6. But if we enter hello and 1, we get an error that the first entered argument is not of an integer type. And when entering a wrong value to the second argument, let's for instance use a list, then we are notified about the second argument not being of an integer type. Now pay attention to Boolean values in here because these return 0 for false and 1 for true. So add true and 1 will return 2. So you might want to create some additional logic for that inside the decorator if that's required. Finally, let's have a look at an example using decorators inside Nuke. Let's say we want to have some super secret functionality that not all users should be allowed to execute. This could also be something about user rights. Maybe you want to have your lead compositors to be able to configure shows, while regular artists should not have the power to configure them. To solve this, we'll create some password protection prior to executing certain functions. Now, there might be several functions that we want to restrict from execution. We can write our password protection once and decorate all functions that would require it. So first let's have a look at our actual functions. Now these are just some dummy functions that create 10 blur nodes and 10 roto nodes in our deck, but these could be any function that you can think of. Now we wrap these functions using a password required function decorator. In this decorator we pass in our function to execute, and in the wrapper we pass in all the arguments that we have now seen several times before. And here comes our interesting logic. In our wrapper function, we create a simple window using nuke.panel with this window title. And we add a password input field, which is like a normal string input field, except that the entered text will be displayed using dots. Then we show the window, and when the user clicks the OK button, we convert the password that the user entered into the password input field to a MD5 hash sum. This hash sum will be checked with the hash sum of our internally used password, which is in this case secret123. Now we use a MD5 hash sum so that we don't store any password in clear text form. You should never store any password in clear text. So this is the MD5 hash sum of our password, which is in this case secret123. To get this value, we can use any MD5 hash sum online generator, type in our password, and this is the MD5 value of it, which we passed in here. Now, normally this should not be hard-coded in here and should rather be stored in a config file, or we should retrieve it from a database or something else. To keep this simple, we'll simply add it in here. So to recap, if the MD5 hash sum of the password that the user entered is different from the hash sum 123, then we'll show a pop-up wrong password and return without executing the actual function that was passed into our decorator. If the password is correct, then this if block won't be executed and we'll execute the function with all passed in arguments. So let's double check that this works. So let's switch to Nuke and execute our create secret blur. And this will show the password prompt. So let's enter an incorrect password, and this shows wrong password and returns without executing anything. And when we enter the correct password, secret123, then this will execute our function and create 10 blur nodes. Now we can do the same for our create secret roto function. So let's type in any wrong password, and this won't do anything. And entering the correct password will execute our actual function. Now, there's a lot more to decorators, and this tutorial was just a brief introduction about this very interesting topic. But I hope this gave you a good starting point about what decorators are and how they work and what they can be used for. Decorators are a very powerful concept in Python which lets us create code that is shorter, more elegant, better maintainable, and reduces code duplication. There are actually multiple more scenarios where using decorators can be a good choice. In another tutorial, we'll have a look at using caching decorators to speed up our programs. I hope you liked this tutorial. If you did, please give a thumbs up and feel free to subscribe to get news about new and upcoming tutorials. If you have any questions, please post them below and I'll try to answer them. And as always, if you would like to see a future tutorial about a specific topic, just let me know. Again, my name is Simon Lukashis, and thanks for watching.